Good day, students. Welcome to Mathgotserved.com. And this clip, we're going to be going over section 11.a of our virtual geometry text on transformations. We're going to be looking at how to reflect geometric figures across the x and y axis. The type of problem that we're going to be covering in this presentation is captured here. Reflect triangle ABC with these vertices about the y-axis. If this is a type of problem you're looking for, don't forget to hit the like and subscribe buttons. And don't forget there are 4 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate mastery of the contents of this tutorial. To gain access to our entire geometry, algebra 1, 2, pre-calc, and calc courses, just take a look at the links in the description below or visit our website at mathgotserved.com. All right, to get us started, we're going to be going over some key vocabulary terms that will be governing our problem solving process today. Let's first of all start with the definition of what a transformation is. Okay, all right, so a transformation, let's put that in green. A transformation is an operation that maps an original figure. Okay, that original figure is referred to as the pre-image. Okay, an original figure called the pre-image. Let's make that blue. So just in case you're looking at the mirror, for example, you yourself, you are basically the pre-image, okay? So the original figure called the pre-image, so the transformation maps the original figure called the pre-image onto a new figure called the image. Okay, so your reflection in the mirror, your image in the mirror is the image. Okay, all right, so that's what the transformation is. It just basically maps a pre-image to an image following a given set of rules. All right, in geometry there are 4 types of transformations. There are 4 transformations in geometry that we're going to be covering, and I'm going to specify them in order. The first one is reflection. Okay, the example I gave with a mirror. First one is a reflection. The second is translation. This is just movement of an object around a coordinate plane. We have reflection, translation, and then we have rotation, spinning an object around an axis of rotation around a point. And then lastly, we have dilation. Dilation is making an object bigger or smaller, enlarging it or shrinking it. All right, so just to keep something in mind, the first 3 are known as isometries or rigid transformations. Okay, so these are isometries or also known as rigid transformation. What does that mean? It basically means that the size and shape remains the same. All right, so this basically means that the size and shape are unchanged. They're congruent. The pre-image and image are congruent. Okay, size and shape are unchanged under these first 3 transformations. We're going to start with the first one, reflection, in this presentation, and then we'll attack subsequent transformations in next tutorial series. All right, so the instructions for the examples that we're working on are as follows. We are to reflect the given polygons about the specified axis graphically, then verify our results arithmetically using the formula for reflection across an axis. All right, so for number 1, we are to do the following. Reflect triangle ABC with vertices A is 2, -1, B is 1, 3, and then C is 5, 0. So we're going to reflect this across the y-axis, All right, and then when we're done doing that graphically, we'll verify our results arithmetically. All right, so let's do it graphically first. Basically, we have to draw the triangle. Okay, we'll draw the pre-image and then the image. All right, so let's see, triangle ABC2, -1. All right, and all the other ones are positive, so it's going to be in quadrants 1 and 4. So this is our y-axis right here, x-axis, sorry, so x-axis, and there's our y-axis. So let's graph the points. Let's graph the pre-image in blue, okay? So point A is 2, -1, 1, 2, -1 down right here. So that's point A. 2, -1. Point B is 1, 3, so 1. And then we're going to go up 3. 1, 2, 3. That's point B. 1, 3. And then point C is 5, 0. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. All right, so that's point C, which is 5, 0. Okay, so now we're going to go ahead and draw our triangle ABC. Let's make that a little bit smaller. So just connect the vertices, okay? All right, so that's side BA, side AC, and then side CB. All right, so there goes triangle ABC. This is our pre-image, okay? So the pre-image is triangle ABC. That's this one. All right, so now what we're going to do is we're going to reflect across the x-axis. What does that mean? To reflect across the x-axis basically means we're going to flip this triangle across the x-axis. Imagine as though the y-axis. Imagine as though the y-axis is the mirror. Okay, so if the y-axis is the mirror, what's going to happen when we flip an object to the right into the mirror? Where is it going to end up in? So this is our axis of reflection right here. What's going to happen is that all the points to the right will end up on the left side, okay? But the reflection will happen in such a way that it's going to be equal distance from the right to the axis. The same distance will be reflected to the left, okay? All right, so let's go ahead and start plotting. All we just have to do is graph the vertices, and then we'll connect the dots, and that will be the image. To graph the image of triangle ABC when we reflect it across the y-axis, okay? So what is that going to look like? When you reflect an object across the y-axis, what is going to happen is that all the points on the right side will end up on the left side, and everything on the left will end up on the right. Okay, in this particular setup that we have right here, we only have points to the right of the y-axis, so all these points on the right will be reflected perpendicularly across the y-axis, and they will end up the same distance but in the left direction. Okay, all right, let's start with point A. If we map the pre-image A to -1 across the y-axis, that will be 2 units to the left. 1, 2, bam. That will be the pre-image of point A, A prime. And the coordinates will be -2, -1. All right, so that's what a reflection across the x-axis looks like. Make sure you are traveling in the perpendicular direction. That's extremely important. So you see how from this, we're going from the y-axis, we go horizontally here, and then we go in the opposite direction by the same magnitude. Notice how my line of reflection is perpendicular to the axis of reflection. That's basically how it works. Alrighty. Okay. And then point B will follow the same pattern. Since B is 1 unit to the right, if we reflect it across the y-axis, it would be 1 unit to the left. That will take us to the image B prime with coordinates -1, 3. And then point C is 5 units to the right, 1, 2, 3, 4, 5 on the x-axis. So point C prime will be 5 units to the left, 1, 2, 3, 4, 5 on the x-axis. So that will be the image of point C, C prime, with coordinates -5, 0. Alrighty, so we'll connect the dots together to draw the triangle for the image of triangle ABC under reflection about the y-axis. Let's make it green. All right, let's connect the dots. Point C prime, A prime. Side C prime, A prime. Side A prime, B prime. And then the last side, side B prime, C prime. Bam. That's what it looks like. Let's label it. This guy right here is the image triangle A prime, B prime, C prime under reflection about the y-axis. So this is a graphical result. Now let's generate our arithmetic verification. To do that, we're going to be using the formula. Alrighty, so let's go ahead and take a look at the formula for reflection across the axis. So let's start with reflection across let's start with the y-axis, just like we have in this problem. Now, the reason why I didn't give the formula initially was that I wanted to give you an opportunity to see if you can determine what the formula is. Now, take a close look at the coordinates of our the vertices for the pre-image and the vertices for the image. Do you see a pattern? So look at A, for example. This is 2, -1, and the image is -2, -1. B is 1, 3, and the image is -1, 3. C is 5, 0, and the image is -5, 0. Do you see a pattern here? Well, you notice that a reflection about the y-axis impacts just the x-coordinate. You take the opposite. The sign of the x-coordinate gets flipped. Okay, so reflection about the y-axis is as follows. Let's write it down. The reflection about the y-axis takes the point xy and maps it to the opposite of the x-coordinate, comma, y. Okay? All right, how about the reflection about the across the x-axis? Can you guess what that's going to be across the x-axis? So if we follow the pattern that we have above here, we can see what it's going to be. So when you were reflecting across the y-axis, the other coordinate, namely the x, you had to take the opposite of that, right? So when you're reflecting across the x-axis, guess what? You take the opposite of the y-coordinates. So it's going to be x, comma, -y. Bam. Alrighty, so this is how we're gonna verify the accuracy of our answers. So we're just gonna make a table of values and then apply our transformation formulas to the vertices of our pre-image and see if the answers we get match the vertices of our image under our graphical reflection. Okay, so we start with xy, x comma y. So this is going to be our pre-image. And then we're going to map it to the image using the transformation is reflection about the y-axis. Okay, so what's that going to do? It's going to take us to, based on the formula that we have down here, -x comma y. So let's apply it to the coordinates. We have A is 2, -1, B is 1, 3, and then C is 5, 0. So just using our formula here, A prime, our image, is just going to be the opposite of the x-axis, so negative 2, comma, negative 1. B prime is going to be the opposite of the x-axis, negative 1, comma, 3. And then the image of C, C prime, is going to be the opposite of the x-axis, negative 5, comma, 0. All right, so let's compare these with what we have in our diagram. A prime is negative 2, negative 1, check. B prime is negative 1, 3, check. And then C prime is negative 5, 0, check. So that shows that our reflection is correct. All right, we're going to do one more example and then give you an opportunity to do some practice. Alrighty, let's take a look at question number 2. So for question 2, we're looking at a quadrilateral this time. We're going to reflect trapezoid ABCD with vertices A, 2, negative 2, B, 2, negative 1, C, 5, negative 1, and D, 5, negative 3 across the x-axis. Okay, so we're going to get started by drawing the pre-image first, trapezoid ABCD. So we're going to go by 2s so that we can have a bigger figure here. So 1, 2, 3, 4, 5. And let's go down 1, 2, 3. All right, let's have our pre-image in blue, okay? So point A is 2, negative 2. So this is negative 2 here. And then that's 2, 2, negative 2 is point A. And then point B is 2, negative 1. All right, so let's put point A right here. A is 2, negative 2. And then point B is 2, negative 1 right here. Point B, 2, negative 1. And then point point C of the pre-image is 5, negative 1. 1, 2, 3, 4, 5. This is 5, negative 1 right here. That's point C of the pre-image, 5, negative 1. And then point D is 5, negative 3. So 5, negative 3. 1, 2, 3 right here. Bam. This is negative 3. This is negative 1. All right, so all we're just going to do now is connect the dots, and then that will give us our pre-image trapezoid ABCD. All right, so let's go ahead and do that. All right, so that's side BC, side CD, side DA, and then side AB. Right there. Okay, let's adjust it a little bit so it looks nice. All right, bring this one up a bit. And then side AB. All right, so there goes our trapezoid. We're gonna name it, okay? So this is what we're about to reflect about the x-axis. Okay, so let's put point D. Point D has coordinates 5, negative 3. This is the pre-image. The pre-image is what is going to be reflected, the original, and it's trapezoid ABCD. All right, that's what we have right here. So we're reflecting across the x-axis. Let's draw our line of reflection so everybody sees exactly what's going on here. So our line of reflection is the x-axis. Bam. So reflecting across the x-axis basically means all the points on the bottom go to the top, and all the points on the top go to the bottom. Exactly the same distance perpendicular to the axis of reflection, namely the x-axis. Okay? All right, so all the points that we have for this particular problem are beneath our axis of reflection, so the points will be reflected to the top. Let's start with point A. A is 2 units down, so we're going to reflect it the same number of units up. So 1, 2, 3. All right, so perpendicular to the x-axis, 2 units up, 1, 2, that's point A prime. That's the image of the reflection of A. Point B is 1 unit down, so just go straight up, 1 unit up, exactly the same distance perpendicular to the x-axis along the point. That's point B prime. The coordinates, well, let's correct A, sorry. A is actually 2, 2, 2. All right, and then point B prime is going to be 2, 1. And then point D, let's do C. C is reflected 1 unit upwards right here. Bam. That's point C prime. Point C prime is 5, 1. And then point D prime, point D is 1, 2, 3. 3 units down, so we're going to reflect upwards, perpendicular to the x-axis. 1, 2, 3. 3 units up will take us to D prime, the image of D on the reflection about the x-axis. So that's going to be 5, 3. Okay? And then let's connect our dots to create the image of trapezoid ABCD on the reflection about the x-axis. So that's side A prime D prime, side D prime C prime, side C prime B prime, and then side A prime B prime right there. Okay, let's make a real quick adjustment with side B prime C prime a little bit too high. Move that down. Okay, so what we just created is the image. All right, the image is trapezoid A prime, B prime, C prime, D prime on the reflection about the x-axis. Now let's verify if our image is correct by applying the transformation formula to the coordinates of trapezoid ABCD. So remember what the transformation formulas are. So this is xy. And then our reflection is, the transformation is the reflection about the x-axis this time. So you know what's going to happen? The y coordinates will switch to the opposite. So it's going to be x comma negative y. Okay, so let's see what happens. Point A is 2, negative 2. Point B is 2, negative 1. Point C is, I'm copying from the original problem, 5, negative 1. And then point D that we're given is 5, negative 3. Okay, let's apply the formula here. For A prime, you just take the opposite of the y coordinates, 2, 2. For B prime, take the opposite of the y coordinates, 2, 1. For C prime, take the opposite of the x coordinates, 5, 1. And then for D prime, take the opposite of the y coordinate, 5, 3. All right, so you just take the opposite of the y coordinates. Let's see what we have here. Let's check it. A prime, 2, 2, check. B prime, 2, 1, just compare with the graph, okay? And then C prime, 5, 1, check. D prime, 5, 3, check. Our answer is correct. All right, so it's now your turn to do some practice problems. Okay, so here are 4 practice problems that we promised that we're going to give to you to try out. So what you're going to do right now, go ahead and pause this video presentation. We'd like you to try out these 4 practice problems. When you are done, click on the playback button and we're going to reveal what the correct answers are. Welcome back. So hopefully you had a chance to try out the practice problems. These are the solutions right here. So I'd like to know how well you did in the practice problems. What did you score out of 4? Let us know how well you did in the comments section below. If you have any questions about the solutions to these practice problems or maybe the contents of the tutorial, just specify your questions and we'll be more than glad to support you. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of geometry, do give us a like or a thumbs up. There are tons of support resources available to you at Mathgotserved.com. So don't forget to subscribe to our channel so you can get updates to all those wonderful resources. Thanks again for watching and have a wonderful day. Goodbye.